So now let us continue with the questions. Now, ammonia can readily dissolve in water according to the equation below. We have the chemical equation. It's ammonia reacting with water to form ammonium ions and hydroxide ions. This reaction, it is acid-base reaction. Like I said, there are many different types of reactions. Yesterday we did redox reactions. This is acid-base reactions. So now we can see that ammonia, it is the base whereby it will accept the proton from water, and therefore it will turn into these ions, and water will turn into that ions. That's very important. So solely based on this chemical reaction, 8.1, they say to us, explain why hydroxide ions, this is hydroxide ions, why a hydroxide ion is regarded as a Lowry-Bronsted base. We said that according to these two guys, these are the scientists, according to their theory, they have discovered that acid, it is a proton donor, a base, it's a proton acceptor. Now, from this question, they say to us, explain why hydroxide ion is regarded as a Lowry-Bronsted base. So that means hydroxide ion, if maybe we reverse this reaction, hydroxide ion will react as a base. That means, how do we define base in terms of Lowry-Bronsted? Hydroxide ion is regarded as a Lowry base because 8.1, it is a proton acceptor. So that means hydroxide ion, it is a proton acceptor. That's why we regard it as a Lowry-Bronsted base. I hope that was clear. Now, 8.2, it says to us, identify the type of bond responsible for the formation of ammonium ion in the above equation. This is what we call the ammonium ion. But we want to talk about the bond that are responsible for this ammonium ion. We go back a little bit from matter and materials. We have learned 3 types of bonds: the covalent bond, ionic bond, and metallic bond. And there is a special case of a covalent bond. That special case, we call it a dative covalent bond, or you can also call it a coordinate covalent bond. But to be safe, I think for this curriculum now they call it dative covalent bond. I don't know if they still call it coordinate, but to be safe, just call it a dative covalent bond. It is also called coordinate covalent bond. So the type of bond responsible for ammonium ion, it is called dative covalent bond. Remember, dative covalent bond, it's a bond that happens between the ions, between the atoms, which shares the electron from one species. Remember, ammonia, it will have lone pairs, and then hydrogen, extra hydrogen will come to ammonia. This is ammonia, right? Ammonia has lone pairs. So these lone pairs, say this lone pair over here, when hydrogen comes, it will come here to pair with this ammonia to add extra 4th hydrogen. So this hydrogen that comes to this will share those electrons from ammonia. Therefore, we call it a dative covalent bond. So the type of a bond is called the dative covalent bond. It's called dative covalent bond, okay? That's 8.2. Now, 8.3, they say to us, write a balanced equation to show how the N4 in the above equation will act as a base when it reacts with hydrochloric acid. Now, let's go to our equation. We have already spoke about the N4 on the previous questions. We said that an N4 can act as either acid or a base. Now, we want to talk about an N4 here. Here, we'll take water as an N4. But now remember, here water, it is reacting with base. Now, they want our ampholyte to react with hydrochloric acid with acid, right? And then we're going to write a balanced chemical reaction. So when hydrochloric acid reacts with water, this is the ampholyte they are talking about reacting with hydrochloric acid. What's going to happen during this chemical reaction? Remember, here ampholyte will act because we have acid. That means ampholyte will act as a base. So HCl is a proton donor, which is an acid, will donate its proton to there. So that means we're going to have Cl minus ion when HCl donate its proton, which is hydrogen ion. And therefore, water will accept that proton as a base, and therefore it's going to be H3O plus ion. Even here, we have a dative covalent bond. Okay, anyways, this is the reaction that is going to take place. Now, let us balance the atoms in this chemical reaction. We have how many hydrogen atoms? 1 on this side of the equation. We have 1 plus 2, which is 3. This side, we have 3 hydrogen atoms. And in the Cl, we have 1, and then here we have 1. The oxygen, we have 1, and there we have 1. So for 2 marks, this is the reaction they are talking about of an ampholyte reacting with acid. At the same time, this chemical reaction, it is most definitely balanced. The question was, write a balanced equation to show how the ampholyte in the above action will act as a base. So we can see that ampholyte has acted as a base when it reacts with hydrochloric acid because it's going to have to accept the proton. This is 8.3. Now 8.4, it says to us, the statement before 8.4, they say 5 cubic decimeter of nitric acid, okay, with a concentration of, you know what, to make things much more easier, let us write information provided. We have volume of nitric acid. Nitric acid, it is HNO3. So what is given about the nitric acid, the volume? It is in cubic decimeters. So we are happy. It's 5 cubic decimeters. This is the volume of nitric acid. And then we are also given the concentration of nitric acid, 5 cubic decimeter of nitric acid with a concentration of, this is the concentration of nitric acid, 0.75 mole per cubic decimeter. So that means, again, we're also given the concentration to be 0.75 mole per cubic decimeters. Is spilled. They say this is spilled accidentally in a small pond of water. So that means we have a pond there. We have a pond of water. Apparently, this spilled accidentally in this water. So the acid, which is nitric acid, and water, here we have water. The acid and water has a total volume of 1,000 cubic decimeters. And that means the total volume of acid combined with water is going to be 1,000 cubic decimeters. Okay, so to neutralize the acid, because remember the pond, it is now composed of an acid. So most of the times we are not happy that the pond, it is acidic. So we want to get rid of that acid by neutralizing it so that we go back to neutral water. So to neutralize the acid, apparently calcium hydroxide, which is our base, is added to water. So in this water, we're also going to add calcium hydroxide to neutralize the acid that is inside of that pond. Okay? Because this pond can be dangerous to species that feed on this pond, or you know, we don't want that acid. Rather, we'd rather neutralize that acid so that this pond can remain again as water. Okay, that's what is happening. It's a scenario that is taking place. So, and then we are given the chemical equation of that nitric acid in a pond and calcium hydroxide that's going to neutralize that acid. And then this is the product that we're going to get. We're going to form salt. Remember, acid and base react to form salt and water. Now, 8.4, it says to us, define the term concentration. We know that concentration it is denoted by this formula. C is equals to N over V. How do we define this term? You're going to look at this formula. So here, you're going to say the concentration. It is, you can use number of moles, or you can just use the solutes. Solutes are the substances that you're going to add in a solution to dissolve. So that means you're going to say the concentration as a solute of a substance per liters. Back then, they used to say per unit volume. So let me define it over here. 8.4, we're going to say solute of substance per, we used to say per unit volume, but now apparently they say per liters. Okay, this is how we define concentration. This is solute and this is liters because it's a volume, right? And this is the solute. It's number of moles of a substance. That's how we define it in a simpler way. So 8.5, let me come here. 8.5, it says to us, calculate the concentration of acid after it was spilled in the pond. Now remember, this is the pond, right? After, we want to know the acid. Look, this is what is happening, guys. Pay attention, and I want you to understand these questions. These questions are fun and nice. So to answer 8.5, I get it. We said that acid will be inside of this. So acid now, look, acid, it is now under this volume, 1000. Remember, initially, this acid, it had the concentration of 0.75 with under this volume with 5 cubic decimeter. So we want to know that when this acid now experiences high volume, I get it under 5 cubic decimeter, this is the concentration. But under 1000 cubic decimeter, the concentration, it is most definitely going to be the same because now we have high volume. That means this acid in a pond will be concentrated. It won't be concentrated as much as it was concentrated under a volume of 5. So question says, calculate the concentration of the acid after it was spilled in a pond, meaning we want a new concentration under this volume, which is 1000 cubic decimeter. Remember, the number of moles of HNO3 when it was under this volume and this concentration is the same as number of moles in a pond. So the number of moles that we're going to get over here is going to be the same as number of moles that were spilled in a pond. So that means you're going to have to calculate number of moles first here, and those number of moles, we're going to plug them here to determine the new concentration under this high volume. So let us do it. So let us determine number of moles first. The number of moles of this thing is going to be C multiplied by V, whereby it is concentrated. It is concentrated because volume, it is weak, it is less, meaning we have smaller volume. So now the concentration of HNO3 in this case, it is 0.75. And then the volume in cubic decimeter, it's going to be 5. Now let us punch this on our calculator. So we're going to say 0.75, 0.75 multiplied by 5. And then we get 3.75 moles. 75 moles. This is the number of moles of concentrated nitric acid. Now, let us determine the very same number of moles. We're going to use them here in a pond to determine new concentration. So we know that C is given by N over V, but here it is now diluted. Why our nitric acid, it is now diluted? Because we have now high volume. Imagine you taking a island juice, this juice that you add water onto. When you add extra water, when you add more water, what's going to happen with that juice? It's going to be diluted, right? Meaning the concentration will decrease. It won't be high concentrated. So here, look, volume is 1000. So that means we are diluting. So we want to determine new concentration. We're still using the same number of moles. I don't have space. Let me just write here. Number of moles It's the same that we calculated, which is 3,75. Divide by, what is the volume? Now volume is 1,000. 1,000 cubic decimeters. Now let us divide. We're going to say 3,75 moles divided by 1,000 cubic decimeters. We get new concentration to be 0,00375 mole per cubic decimeters. So this is how we answer question number 8.5. This is how we get the concentration after carbon is diluted, because it is under 1,000 cubic decimeters. So that's how we answer question number 8.5. Now 8.6, it says to us, use calculations. Now it's 6 marks. We move into 6 marks. Use calculations to determine if 120 grams of calcium hydroxide, which is this one, will be sufficient to react completely with all the acid in the pond. I'm going back. Remember, this is our pond, right? Remember, we added calcium hydroxide to neutralize that acid. So this acid in a pond, it has this concentration over here, the one that we have just calculated. Now, because we have high volume, do not forget that. So it is diluted. So in this pond, remember, we added calcium hydroxide. So this is what we're going to do. We're going to calculate the mass that is needed. We're going to calculate mass that is needed, that is going to react with this acid, the mass of calcium hydroxide that is going to neutralize this acid. We're going to calculate it mass. And therefore, the mass that we get here, we'll compare it with this mass, and then we'll conclude from there. But firstly, how are we going to do that? Now, from this balanced chemical equation, right? From this balanced chemical equation, this is what we're going to do. We have 2 moles of what? Of HNO3 is to how many number of moles of calcium from this balanced chemical equation? It's 1. So we have 1 mole of calcium hydroxide. Now, let's go back to our calculations to see if maybe we have something. So we said, how many number of moles of this thing, nitric acid, do we have in a pond? Calculated, we said it's 3,75. So number of moles is 3,75 moles of HNO3. But we need number of moles so that we can determine mass. But we need number of moles of calcium hydroxide that's supposed to react with this thing. So we need number of moles of calcium hydroxide. We cross multiply this multiply by this, and this multiply by that from the ratios. 2 multiplied by n is going to be 2n calcium hydroxide, which is equals to 1 multiplied by 3,75 is going to be 3,75 moles. And therefore we divide by 2. So 3,75 divided by 2. On my calculator, I get number of moles of calcium hydroxide to be 1,875 moles. So this is the number of moles of calcium hydroxide. So let us determine mass of calcium hydroxide. So mass of calcium hydroxide is going to be number of moles multiplied by molar mass. So number of moles is going to be 1,875. And then what is the molar mass of calcium hydroxide? Remember, calcium from the periodic table is 40. And then we're going to multiply 2. We're going to say, okay, let me just write 2 here. Because of these 2, we're going to multiply oxygen and hydrogen. So oxygen is 16 and hydrogen it is 1. And then let me close my bracket. And therefore, let us punch everything on our calculator. 1,875, open bracket. I'm going to say my answer, open bracket, 40 plus 2, open bracket, 16 plus 1, close bracket twice. And therefore, I get my mass, this mass of calcium hydroxide, I get 138.75 grams. This is the mass that is needed from calcium hydroxide to react with nitric acid. So the question was, determine if 120 grams of calcium hydroxide will be sufficient to react completely with all the acid in the pond. No, it won't be sufficient because apparently this is what we need. We need 138.75 grams. And here we have 120. 120, it is very, very less. You see, so we need higher mass compared to what we have over there. So that means 120. No, 120 grams will not be sufficient, since from the calculations we need 138.75 grams from calculations. So that means 120 grams, it won't be sufficient. 120 grams of calcium hydroxide, it won't be sufficient to react with that acid. Apparently, this is what we need from the calculations. So that means we're supposed to determine mass that is needed to react with that acid. So we get 138. So this is a very high mass. So 120 won't be enough. And I hope that question was clear enough.